Hey, the OpenC3 team is back again. Welcome, everybody. We have part of the team here today. We have maybe a few months since we did one of these videos, so lots to talk about. What we've been doing. We're also going to talk a bit about what we will be doing. But before we get to any of that, it's always good to do a round of introductions. I'll start off. My name is Greg Bond, COO here at OpenC3.
Hey guys, hopefully you know me, but I'm Ryan Melton, CEO of Cosmos and OpenC3.
Hi, Jason Thomas, CTO of OpenC3.
I'm the other Ryan here at OpenC3, one of our developers.
And I'm Chris Haller. I'm our Chief Marketing Officer.
Awesome. And I do want to point out there's actually more OpenC3 Cosmos knots on the team that are not with us today. They're off doing work. But we started 2025 with 3 employees here at the company. We are closing out the year at 8 employees. This has been a banner year for us, just like it's been a banner year for the space industry. We're very, very happy to have all our folks new to the team, all our new customers this year, and as we do, more and more of these videos, and you see us in more places, definitely say hi. It's a great group, and we're always looking to, meet new and existing Cosmos users out there. Kind of on that note, I think we've also got some other really exciting things to kind of catch up on from the last few months. And I'm actually going to throw it over to Ryan Melton to talk a bit about the Space Software Summit.
Yeah, so for those of you who didn't make it, it was amazing. So October 6th through 8th this year in Boulder, Colorado at the Embassy Suites, we had an amazing Space Software Summit conference with 250 attendees from 100 different companies from all over the world. And it was 3 days of workshops and talks and breakout groups and vibe coding and all kinds of fun stuff, debates, and a lot of Cosmos stuff as well. So it was the place to be if you're doing anything related to space software in the industry. It was an awesome conference. And kind of with that, we just booked the hotel for next year. So next year we want to be even bigger. We're going to be shooting for around 350 people next year. So kind of almost a doubling from the previous year. And to do that, we went to a bigger venue. So we've moved to the Marriott Westminster Denver Hotel. It is about twice as big of a space as we had in the Embassy Suites in Boulder. And so that is going to give us just an awesome venue to have even better, more talks, more workshops, more space software all at one place at the Marriott. And so that's what you can look forward to next year. It's almost the same dates. It's October 5th through 7th. So mark that on your calendars and be there next year for the Space Software Summit 2026.
Yeah, it was fantastic. And huge shout out to Chris on the call here. I think a lot of our attendees learned about it through his efforts. So huge thank you to Chris and everybody who contributed to that and attended. And honestly, the growth that Ryan described from our 25 conference, our Space Software Summit to our 26, that's kind of just typical of the company right now. And there's a lot of ways to kind of describe that growth. I do want to share a little bit too about our international growth. So I actually just went through all the places outside of the U.S. that are now Cosmos Enterprise customers, and I'm just going to quick hit the list here. It's the Netherlands, it's Australia, it's Sweden, it's Finland, it's Germany, it's France, it's Luxembourg, it's Italy, and it's the U.K. And there's more in the pipe. So we wanted also just highlight how appreciative we are of the larger community, just doing fantastic work in the space business, and space is truly a global business, and we're super proud to be a part of that. So always want to just kind of highlight and help people understand what our story is. And to kind of round that out, I do want to throw it over to Chris to talk a little bit about our 2026 conference planning.
Yeah, so met a whole lot of people during 2025, and we're looking forward to doing it again in 2026. We're still building out the conference schedule, but right now you can plan to see us at Commercial Space Week in Orlando, January 28th and 30th, GSAW in LA, February 23rd to 26th, Satellite in DC, March 23rd and 26th, Space Symposium in Colorado Springs, April 13th through 16th, SmallSat in Salt Lake City, Utah, August 23rd through 26th, and of course, our own homegrown Space Software Summit, as Ryan mentioned, in Westminster, Colorado, October 5th through 7th. And more conferences to come soon. So if you're at any of those conferences, please stop by the OpenC3 table, grab a hat, say hi to Cosmo, the self-balancing Cosmos robot, and the rest of the team.
All right, we would not be doing an OpenC3 video if we did not actually talk about some of the amazing new OpenC3 Cosmos features. These ones have actually been released or about to be released here in the next few days. And we'll just kind of go through, and I think a picture's worth 1,000 words, so we've actually got Cosmos running here. And the first thing we want to talk about is command queues, which is a very cool new feature that Jason's going to walk us through.
Yeah, we implemented command queues for a customer that really wanted this queuing paradigm that they'd use in another type of mission planning system. So we have this whole new UI for command queues, and basically all of our stuff, just like everything in Cosmos, is API driven. So I wrote this script to both create a queue, load it up with a bunch of commands, and it's as simple as adding the queue name that you want to put on existing commands. And so we're going to run this, load it all up, and remove a few commands, and then just wait. While this thing is happening, we're loading all these commands up. This is just an in-order list, and I can now execute individual commands. I can edit them, so I can execute this one just by clicking play. I can edit this thing and say, you know what, actually I don't want this to be a no-op anymore. I want to arm the laser and update that command. This thing is just waiting for all of these commands to execute. So right now I'm in hold mode. We can also disable the queue by disabling it. At that point, when I try to add a new command, it raises an error because it can't add it to the queue while it's disabled. If I hit go again, I'm going to put it back into hold mode. So now it's in hold, so I can edit it. I can run these commands. I can take something off the queue if I don't want to execute this later. So it's this list of commands that are about to go out. And the final thing in the script is going to release the queue. If I hit run, all of these commands will now get executed in the background. So I hit go, and now we're in release mode, and everything's just streaming out just as if you were sending this in a script. So it gives that particular customer a really cool way, a ConOps that they were used to loading up an entire list of commands. Then they can review them, add, remove, and then execute them when they get into a contact. So if that's something that's interesting to you and you don't want to write a separate script for that, that's typically how we've done it. This queue feature is a really cool new way to interact with Cosmos.
I love that. Thank you, Jason. I think this is like a testament to whatever way it is that you control your hardware. Cosmos, has a way to, match your ConOps. That's fantastic. Awesome, thank you. And I think Ryan Melton is now going to talk to us about one of the most visually impressive changes that we've had recently.
All right. So if you look so 6.8, the key feature was command queues. 6.9, our key feature in the system, which we put a lot of other stuff in there, but this was kind of like the highlight feature, was this new data flow tabs here on the command flow server, and also the details buttons on the individual interfaces. But let's go into the main data flows tab. That kind of shows you the big picture. So what this does is it shows you all of the interactions of Cosmos between interfaces and targets. So on the left side, we have actually the Cosmos internal processing. So that's where we're doing DCOM and like the internal processing parts of Cosmos. In the center is the actual interfaces and routers. It does show routers as well. So that fourth one down there is a router. It shows you which interfaces and routers are connected to which targets. So it's a very easy visual way to see, hey, does this interface actually talking to 3 different targets, or is it just talking to 1, or is it talking to none? And in this case, we just have 1 at most for any of these. But if you did have multiple targets, you can imagine multiple lines coming out of those center boxes going over to multiple targets on the right, and you can see that they are related. Now, that's the boxes. That's the difference. The boxes on the right are the actual targets themselves, the actual hardware. Now, there's also 2 sets of lines. The right set of lines is target mapping. So that is, does the interface know about the target? And there's 2 lines. There's one for commands and one for telemetry. So does each interface have the database of commands and telemetry for a given target? So why does that matter? Well, the interfaces have to have the database to be able to identify packets. So if I'm having a target with data flowing in and I have the database, I can identify those packets and understand what they are. If I didn't have that database, then the interface would be like, here's some bytes. I don't know what it is. I'm just going to say unknown packet and spit that out to the world. So that mapping is what gives an interface or a router information about targets. And so that's what those right side lines are. And you can delete them live, you can add them live, and that will, in this case, it does respawn the microservice if you change those settings, because it's kind of it has to load a database and kind of restart. But you can do that dynamically through this data flow chart. The lines on the left are different. Those are controlling whether or not the commands or telemetry are enabled going from an interface to the internal processing. So what that means is if I try to send a command that is not enabled, it will go to the interface and the interface will say, well, this command isn't enabled, and it just drops it. Why would you want to do that? Well, sometimes you have the same target mapped to multiple interfaces, but you only want commands to go to one or the other. And a way that you can enforce that now dynamically is by controlling which interface has the commands enabled. So if you just have one out of the two that have the commands enabled, well, that's the only place the commands are going to go, and they're going to flow out that interface rather than the other one, which also knows about that target, but you don't want the commands to flow through that interface. So that's one meaning. Also for the telemetry, it controls whether the telemetry goes through our processing. So if you disconnect the telemetry enabled line there on the left, that will prevent any telemetry coming out of that interface from getting processed. And again, why would you do that? Well, maybe you have telemetry coming in through multiple channels and you really only want one of the channels right now. You don't want the other. Well, this gives you the ability to delete that line, and now telemetry from that interface won't be received by Cosmos. It'll only be received by the other one. Can prevent duplication, and it's also kind of a way to, like, maybe you had nothing wired initially, and then you do the kind of the rubber band like Jason just did there, where you drag the line across, and now you've wired stuff in, and now it's connected, and now it's live, and it's going to actually process the data in Cosmos. So a different way of interacting with the system. One other key thing I want to highlight is you can also see protocols. And this is something you couldn't do before at all. So those little orange and blue boxes there are the protocols attached to the interface. And so if you click into like that length protocol there at the top, what this does is it gives you the data at the protocol level. So I can see the data flowing into the protocol and out of the protocol. So you can see how it's manipulated within the protocol. In this case, it's a read protocol. So you can see the raw data coming in and the raw data coming out. And I don't know what this protocol is doing. It's the length protocol. So it actually, you can see the top one has, it looks like, 30, doing live math, 3 times 16, 49 bytes of data. And then the bottom one has less. So something in the protocol, it removes some bytes from the data. It looks like it probably discarded leading bytes of 4. And so that protocol, you can see how the protocol actually manipulated the raw binary right there in the system. Also on the left, you get all the protocol settings. So if you need to see, like, how's my protocol configured? What's it doing? You can see all the different protocol settings and the property values pairs on the left. So a nice way to get insight in what your protocols within Cosmos are doing that we didn't have before. And that's my semi-quick discussion of the new data flows tab.
This is super exciting, and I want to give a huge shout out to our customer base. They are deploying Cosmos in more and more sophisticated and large environments. And that is what pushed for this new feature and this new way to visually understand these large deployments. And again, our customers are the best, and they're constantly helping us make this product better. Thank you. So the next one we want to dive into, and Ryan Pratt's going to lead us through this. This is, not the feature stuff that we usually include in these videos, but it's just, if not more important, and I'll throw it to Ryan Pratt to walk us through that.
Yeah, absolutely. So security is obviously super important, and that's kind of what Greg was hinting at here. Over the past several months, we've seen some, seems like an increasing frequency in attacks through specifically NPM packages, especially around stuff like crypto mining and credential exfiltration, which is particularly scary. One of the pieces of malware was called Shai Halud, named after the word in Dune. That one was pretty scary, and there was kind of a Redux 2.0 after that. Many of you watching might already be aware of these, but effectively, or essentially, it was malware that was included in packages that were published to the NPM registry. And the way that the attacks worked was through post-install scripts. So when you install a package from NPM, it can actually execute code on your machine. And what we have done to kind of protect against this is we've switched our package manager over to PNPM. which is the way that the industry is moving right now. And that by default does not allow that code execution. So it prevents this type of attack. Additionally, we have pinned our versions to the lock files. So previously, if you ran Cosmos by pulling our containers, like our pre-built images, Docker images, you would get the same SBOM, software bill of materials, every single time. But if you built Cosmos from source, you could potentially get different versions, and you might have a different SBOM. Now that we're pinning things, as long as you are building the same release or the same commit, you'll get the same, consistent versioning there. And then lastly, what we've done, and this kind of ties into both of these, PNPM has a feature called minimum release age, which was, it lets you specify only update to a newer version of a package if it's been published for a certain length of time. And so we are currently have that turned on and set to 1 day. And what that does is, it's again another preventative measure against these types of attacks like Shai-Hulud, where it all happened in like the span of a few hours. The community figured out what was going on and shut it down, but those few hours, if you never downloaded that version, you missed it. So we are hoping to avoid that with this as well.
Awesome. Yeah, incredibly important stuff, and we're putting a lot of our focus on, staying at the industry leading edge of this kind of security. So thank you, Ryan. And then last on our list today, when you see this video, you'll likely be able to get Cosmos 6.10 as well. And Ryan Melton is going to walk us through one of the big new features there.
Yeah, so I don't have anything really to show you yet for this. It's more kind of a back-end type technology improvements, but there's a couple exciting ones involved in Cosmos 6.10. The first one is we now have a way to handle what's called channelized telemetry. Channelized telemetry is where you have multiple fields within a packet, and the packet contents are kind of a mystery before you start. So you have to dive in the packet and you say, oh, here's packet item ID, so IDs per item, ID 5. Well, what does that mean? Well, that's the, solar array temperature. And you have to kind of do this lookup between ID and contents. And you end up with these kind of very dynamic packets that are didn't fit into the previous Cosmos paradigm of you have to kind of define your packet contents as a static list of this is what's in my packet. Well, with channelized telemetry, there wasn't an easy way to do it. You could do it with a bunch of code, but there wasn't really a config file way of handling that. Well, now in Cosmos 6.10, there is, and it's through something we call subpackets. The way we've defined that is now you can add a subpacketizer to your packets. It's another kind of class add-on to a code modularity point for your packets. And what that does is it's code that knows how to break up the packet into subpackets. And that solves all kinds of problems, and for not just channelized telemetry, but also other use cases as well. But for the channelized telemetry, what it does is you can break each channel into its own subpacket. And then what we do on the back end is each subpacket is effectively its own time series. So especially as we're kind of hinting into Cosmos 7 with our time series database being a core feature of that, each of those subpackets can become its own time series off in that time series database, and that allows you to then graph them individually with their own time state, their own data rates. So not every packet is going to have every sample in channelized telemetry. So now I can only log the real samples that I received. I don't have a bunch of emptiness in between the samples for the packets that don't have certain channels in them. And that gives you a nice contiguous time series data without nulls in the middle. So that's a nice kind of bonus feature to having the channelized telemetry. Additional feature that's coming in Cosmos 6.10, besides the channelized telemetry, is that you can also do embedded structures within a packet. And what that means is that every packet in Cosmos has what's called an accessor. An accessor knows how to understand the buffer and handle the buffer as JSON or YAML or CBOR or XML or HTML or whatever the buffer contents are. Well, before you had one accessor for a packet. And that works great, except when people do crazy things that they keep doing all the time. Is like, hey, I want, this packet with, a JSON section and maybe also a protobuf section. Oh, okay. Well, so now Cosmos will be able to handle that going forward with 6.10 as well. And what it does is you basically define your structures as additional packets, but they're marked as virtual. So you add a virtual flag to them. That virtual means I'm just a structure. I'm not a real packet. Don't identify me, or don't try to identify me with data coming in, but you can use me as a structure. And then within the packet contents, you can say structure and reference that other structure target name, packet name for that structure. and that'll bring that in as like a mid-section within the packet, and it also flattens it. So you don't have to like dig into the different fields. It just gives them top level names for all of the items within that structure. That allows Cosmos to very easily put them on screens, graph them, everything for with structures within packets. So it's a cool way of nesting concepts within Cosmos. And so when you get into weird data structures and you're like, how do I handle this? Well, here's a new way you can handle it by directly implementing those structures within your packets.
This is going to be huge. This is going to unlock doors like F prime compatibility. This is going to unlock a lot of really bespoke protocol doors. So early days here, but super exciting. Thank you, Ryan. And we do want to bring it to a close here. I just got to say, this team does not stop building. We've got more coming. We have a giant release, like a major revision coming up soon. You're going to hear all about it. Stay with us on LinkedIn, get on our mailing lists, hit up our YouTube channel, and there's going to be a lot more great content coming. We'll talk to you soon. Bye.
Thanks, everybody.